Binomial Theorem, Part 2. In the first part, we have already introduced how to expand a plus b to the power 6 and a plus b to the power 10 or 2x plus 1 to the power 7. How about a plus b to the power 20? Maybe you need to construct the Pascal triangle and then up to the 20 row to find the coefficients. Maybe you do not want to draw the Pascal triangle to the 20 row. Do we have another way to find the coefficients? Now I want to introduce what is the meaning of binomial coefficients. How to use your calculator to find the binomial coefficient without draw the Pascal triangle up to the 20th row. First of all, I want to introduce one of the notation called NCR. N is the number of rows. So, for example, if I want to find the coefficient of 20th row, so this N is 20. How about R? That means the depends on the term. For example, the first term is 0, the second term is 1, the second term is the third term is 2. So what is the definition of NCR first? Okay, NCR is n factorial over n minus r factorial times r factorial. What is the meaning of factorial? Factorial, for example, 3 factorial. That means I want to find from 3 and decrease 1 to 2 until 1. So 3 factorial is 3 times 2 times 1 is 6. How about 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay, you can also use your calculator to find the values of 6 factorial. The answer is 720. That means if you want to find the 10th row of the Pascal triangle, next time you can use your calculator to find 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, up to 10 choose 10. The last term is 10 choose 10. And use your calculator, you can find the first term is 1, is same as the value is same as the Pascal triangle, and this is 10, and this is 45, blah, 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 okay? So I want to give you the general form of the binomial expansion. If a plus b to the power n, what is the general form? Is a to the power n plus, because nc0 and nc1 is equal to 1, so maybe sometimes you can ignore it. And then plus nc choose 1 a to the power n minus 1b, the degree of a is decreasing, and then the degree of b, the power of b is increasing from 0, 1, 2 up to n. So example 1.16a. Expand the following by using the binomial expansion. If you remember the Pascal triangle, maybe you can, during the exam, you can use the Pascal triangle. If you do not remember this Pascal triangle, simple. It's 2x to the power 4 plus 4c1, 2x to the power 3, and 5y, and plus 4c2, 2x to the power 2, and 5 y squared, and then plus 4c3, 2x to the power 3, and then 2x to the power 1, 5y to the power 3, and then the last term is 4c4. Maybe you can ignore it because this is equal to 1 and to the power 4. And then use your calculator and simplify the answer. So the answer is 16 times x to the power 4 plus 160 x to the power 3 y plus 600 x squared y squared plus 1000 x times y to the power 3 plus 620 y to the power 4. But what I want to emphasize is that the binomial expansion, maybe you can use this to expand it, but the main point or the one of the application is the general form of the binomial expansions. If I know, for example, I want to expand it. I need to know what is the general form of this binomial expansion. The general form is NCR to the power time 3a to the power n minus r, and then time negative 2b to the power r, and then this time the r is equal to 5, so maybe you can change it to 5. If you want to find the first term, that means substitute r is equal to, remember, is 0. The first term is 5 minus r, okay, remember 5 minus r. And then the second, this term is to the power r. And when you want to find the second term, is r is equal to 1. If you want to find the last term, r is equal to 5. Why? Because sometimes we only want to find a specific term rather than find the whole term. For example, I want to know what is the coefficient of a squared and then b to the power 3. What is the coefficient of a squared and b to the power 3? That means when r is equal to 3, I can find the coefficients. Then you can substitute r is equal to 3 and write down the coefficient directly. Let's see some example. Page 19. Question example 1.19. Find the constant term in the expansion of 2x squared plus 1 over 3x squared all to the power 6. What can we do? I can write down general term. I mentioned before, general term is 6c r times 2x squared to the power 6 minus r times 1 over 3x squared to the power r. Simplify it. I group all the coefficients together. 6cr times 2 to the power 6 minus r times 1 over 3 to the power r. Because I can separate this term to 1 over 3 times 1 over x squared to the power r. I just want to group all the coefficients together and then remain x term and try to simplify it. For the first term is x squared to the power 6 minus r times 1 over x squared to the power r. And then simplify. This is x to the power 12 minus 2r, and then 1 over x squared is equal to x to the power negative 2, so to the power r. So the answer is times x to the power negative 2r. X to the power 12 minus 4r. Because I want to find constant term, when 12 minus 4r is equal to 0, r is equal to 3. So the constant term is equal to 6c3 times 2 to the power 6 minus 3 times 1 over 3 to the power 3. The answer is equal to 160 over 27. That means I can find the constant term without expansion. Maybe you will ask, okay, this method is very clumsy, it's not very fast. Because I do it step by step, so that maybe you can see I need to write down a lot of steps. But next time, maybe some step we can skip it and then you can find the answer immediately. Okay. Try to do the for exercise 15 And then let's discuss the questions during our lesson.